Okay guys, in this lessons right here, we're going to find domain of two functions, okay? So let's look at number one. Now, in number one, it says for each pair of function f and g, determine the domain of the sum, difference, and product. So whether we add, subtract, or multiply these two functions right here, their domain is going to be exactly the same, okay? So let's look at one at a time. Now, when we look at functions domain, all we really care is at the denominator, right? And if you look at this right here, the denominator down here is a 1, and this is a 1. So if we can't make the denominator into something that's undefined, and undefined means like a number over 0, then these functions, when we add them, subtract them, or multiply them, will always be all real numbers. Because if you were to grab these two right here, one is going to be a parabola, like the first one's going to be a parabola, and the second one's going to be a line. And remember, these domains for these two functions, they're all real numbers, okay? So for this one's right here, the domain is going to be, we're going to write it using set notation, okay? So sum, difference, and product. For all of these two functions, it's going to be x such that x is all real numbers. And that is the notation for all real numbers. You don't have to write it out. Just use that symbol, okay? Okay, let's move on to number two. Number two, same directions, but notice that this time we have, you know, something at the bottom, right? At the denominator. So if you look at this one, it says 3, and this is x plus 1. So for 3, you can make it into a 0, so there's nothing you can do with the first function. But the second function in g, if we solve for x plus 1 equal to 0, x equal to negative 1. What this means is that if we were to plug negative 1 into this x right here, it's going to make the domain undefined at that point. So if these two functions combine, like sum, product, and difference, if we combine these two functions together, it will always cover everywhere left and right except at negative 1. Okay, so this is how you would write the answer for the domain. X such that x is all real numbers except at negative 1. Because at negative 1, it makes the function undefined, so you can say it's all real numbers, okay? Okay, let's move on to number 2. So in number 2, we have f and g, right? So all we care is up to the denominator, right? So this is over 1. So for 1, we can make it into a 0, so that's not going to help. But the first functions right here, we can make it into a 0 if x equal to negative 2. So what that means is that for the sum, difference, and product, the domain is going to be x such that x is all real numbers except at negative 2. Because at negative 2, those the f function is going to be defined at that point. So that's why we cannot have negative 2 in there, okay? Okay, let's move on to the next one. Okay, so this time we have 3 minus x and 2x minus 4. So the first function, this cannot be at 3, right? And this cannot be at 4. So we're going to write sum, product, difference. So x is going to be all real numbers except at 3 and 4, because at those two numbers, the function is undefined. So that's why we cannot have 3 and 4 as our domain, okay? Okay, let's move on to 4. Okay, for number 4, this is over 1, so we cannot make 1 into a 0, so that's okay. But here, this one's right here. If you look at this, it's not okay at x equal to 1/2, right? So x such that x is all real numbers except at 1/2. For number 5, it's going to be x such that x is all real numbers except at 1 and 5. Okay, because at 1 this is going to be 0, at 5 this is going to be 0. Okay, okay, so that's some difference in products. Let's cover division 2. Okay, so determine the domain of f divided by g. So f divided by g means 2x squares over 3x minus 2. So for division, you have to set up the functions like this, and then you look at the domain from here, okay? So again, we're gonna we look at the bottom, and that right there is 3x minus 2 equal to 0, 3x equal to 2, divide both sides by 3, x equal to 2/3. So what this means is that it works everywhere. If we graph the function, it works everywhere except at 2/3. So our domain is going to be x such that x is all real numbers except at 2/3. Okay? Okay, let's move on to the next one. So number 2, it's going to be f divided by g, 3x minus 1 over 4x. So for this one right here, we plug in 0, it will be undefined at that point. So that means x such that x is all real numbers except at 0, okay? Okay, let's look at number 3. So f divided by g, which is 1 over x minus 2 divided by x plus 1. Now I'm going to rewrite this a different way so that way you see it. This is the same thing as x minus 2 divided by x plus 1, right? And then we're going to change this to multiplication. And then you have to flip the second part, which is 1 over x plus 1. So now you have to look at the bottom, right? So for this one, it would not work at x equal to 2. And this one would not work at x equal to -1. So that means my domain is x such that x is all real numbers except at 2 and -1, okay? Sorry. Okay, so for this one right here, we're just going to do number 4, we're not doing number 5, okay? It would be f of divided by g, which is 1 over 3x minus 2. Put this over 1, and then we have 3x minus 2 times 1 over 2x plus 1. So this one right here would not work at 2/3, and this one right here would not work at -1/2. So my domain is x such that x is all real numbers except at 2/3 and -1/2. Okay, guys? So go ahead, complete number 5 on your own, okay? And if you did it correctly, it would be x such that x is all real numbers except at 8 and 5 over 7, okay?